In question 8, I'm telling you what the zeros are, so it's very similar to what we've been doing in the last few, just that we have to make the entire polynomial out of it. So if you're given the zeros are negative 5 and 3 minus 2i, one of the facts that you got to remember is if 3 minus 2i is in there, the other factor has to be 3 plus 2i. So these complex numbers never come alone, they always come in couples. They're called complex conjugates. So these are the zeros, and from the zeros what we know is that when x is a negative 5, it's a 0, which means when x plus 5 equals 0, it's a factor. So I need an x plus 5 in my factorization. I also know when x equals a 3 minus 2i, it's a 0, which means when x minus 3 plus 2i equals 0, that is my factor. So I need one of those, x minus 3 plus 2i. And the final one comes from this one. If that is my 0, 3 plus 2i, then I can get the related factor by saying I know my 0 is when x is 3 plus 2i, which means that my factor had to be x minus 3 minus 2i in order to be a factor that's equal to 0. So these are the three factors that we need to multiply together to get our polynomial. So I would highly recommend that you multiply these two together first. I've been telling you that all along. It just makes a whole lot of sense when we get rid of the i's after our first round of multiplication. So it's going to be x plus 5 that we're going to take times. We're going to multiply it by whatever we get out of this product from our multiplication here. So, all right, so I got to take x times x, which is x squared. And I got to take an x times a negative 3, which is a negative 3x. I take an x times a 2i, which is a positive 2xi. Then we want to just multiply it through by the negative 3. So it's negative 3 times x, which is a negative 3x. That's a negative 3 times a negative 3, which is a positive 9. That's a negative 3 times 2i, which is a negative 6i. Now we're going to distribute through by the 2i. 2i times x is positive 2xi. Okay, I want to go back to my pink one for a second because I think I had, well, here's what I made a mistake on. I'm not going to start this video over. I'm going to make this quick adjustment. When I wrote this down, this was supposed to be minus 2i, and this is going to be salvaged pretty quickly. So minus 2i, which makes this a negative 2xi. So coming back, when I take that x times a negative 2xi, it's negative 2xi. And when I was going through by my 2i, I noticed that because I know the i's have to cancel when I multiply these together, so that's a positive 2xi. So these are going to reduce. They always have to drop out if I multiply those two together first. And then I got to take the 2i times a negative 3, which is a negative 6i. Okay, well now I got to patch that one because if you remember, I got that one by, I'm sorry about this. I got that one by taking 3, negative 3 times, then I had that positive 2i, so now it's going to become a positive 6i. Once again, I was able to sniff that mistake out because I know these i's should cancel. So those are gone. And now I'm going to take the 2i times the negative 2i, and that's a negative 4i squared. But you got to keep in mind that an I squared is equivalent to a negative 1. So just thinking off the side here, this is really negative 4 times a negative 1, which makes it a positive 4. So this positive 4, I just will park it underneath that positive 9 and get rid of it here. And I'm going to collect those like terms, and I still got to multiply by x plus 5. So x plus 5 times x squared minus 6x. These dropped out, plus 13, and these dropped out. Now I got to distribute by the x plus 5. So x times x squared is x cubed, x times negative 6 is negative 6x squared, and x times 13 is 13x. Then I got to multiply by the 5, so 5 times x squared is 5x squared, so positive 5x squared. 5 times negative 6 is negative 30x, and 5 times 13 is a positive 65. Collect my like terms, and I'll have a polynomial of least degree with integral coefficients. So x cubed minus an x squared minus 17x plus 65. This is the trinomial, or the third degree polynomial, the cubic function that has solutions or zeros that were given to us back in the beginning of negative 5, 3 plus 2i, and 3 minus 2i.